Hey everybody, this is Larry. This is me going over Q4 of the weekly contest 266, maximum path quality of a graph. So this one wasn't that hard of a problem conceptually. No. Let me step back. So this one is one of those gotcha FOIA problems, if you ask me. But the solution can be simple, and I'll tell you what I mean in a second. In that second, hit the like button, hit the subscribe button, join me on Discord, talk about this problem, talk about other problems, talk about any contest problems. There are a lot of smart people in there, including previous contest winners. So yeah, anyway, so one thing I would, maybe this is, I'll go about this a little bit different than my other videos, but in that I actually found this problem a little bit misleading in that okay, right, they give you the problem, it's here, is this very general problem, there's a lot of weirdness, they do give you a note, but the reason why this problem is more of a gotcha type thing is that the actual problem, if you ask me, is in the constraints. And reading the constraints and analyzing the constraints correctly is the way to solve this problem. I was a little bit sloppy on this one. As a result, I ended up taking 20 minutes. If you ask me, I probably, like, on a better day, on a day where I'm less silly, I probably should be able to do this in 10 minutes. And I also misread some parts of this. But yeah, so one thing to note is that these are some of the unique nodes and at most max time. But if you're here and you haven't read the problem yet fully, read this problem again and know that I think this is, and why I say this is a gotcha problem is that if you're used to solving these type of problems, you'll get the sense very quickly that this is a very hard problem. And this is a very hard problem in the sense that the complexity is going to be hard, and it is not immediately clear how to make the complexity less hard to fit, right? And on top of that, if you're not careful, and that's what I was not careful, but if you're not careful, you look at the constraints and go, okay, n is 1,000, so we have to do something in linear and or at worst n squared time. So that's something that I would think about at worst. Looking at these constraints, right? And why I say this is a gotcha problem a little bit, or FOIA problem, is because, like I said, most of the problem is in the constraints, and in that sense, there are, to kind of spoil. Okay, so to spoil the answer for you here now is the reason why this is a gotcha problem is the answer is brute force, and the hard part about brute force is not even, at least particularly for this problem, the hard part for this brute force is that it's not an implementation brute force, meaning that the implementation is actually pretty simple, but it's brute force. And the reason why this is a part of a tricky brute force is because all the work is done in the analysis, and all the analysis is in the constraints. And also because of that, because it is brute force, and all the hard part of the part is the proof, if you will. Not a mathematical proof, like it doesn't have to be that rigorous, but a proof to yourself that it's worth the time to even submit, right? Because there is a 5-minute penalty and just like in general. So, but the reason why it's a little bit silly is because as a result, if you're careless and if you're YOLO, basically the reason why it's a FOIA is because or I think is that type of problem is because you can YOLO and get it way faster, even though you cannot prove what you're doing, right? I don't know. That's my opinion. Anyway, we'll go over this problem. So yeah, so as I said, this is brute force. So this is the code. I will mask because I had some bit mask, but this is actually a set, as you can see from here. So maybe I'll change this real quick. And this brute force is very straightforward. I'll go over the code real quick, but we'll go over the analysis in a little bit. Yeah, so this is just converting things to an edged list. So this is pretty straightforward. Here, this is just the brute force. one more thing is that we have to go end back at node 0. So I go, okay, every time we're at node 0, I do this thing where I calculate the cost, and it's basically for each node in the set, and S is a set. For each node in the set, we just sum up the values, which is what they ask you for. If the best is, if you can improve, then you update best. That's straightforward. And then here we just look at the edge list of, okay, if we have time left over and left is time left over. Oh, let's actually define this. Current node. S is equal to unique nodes visited. Left is equal to time left over, right? And this is, and just to also kind of emphasize a little bit, the reason why this is hard is because there are, I used the pen and paper to draw a lot of scenarios, and I didn't have a heuristic that could solve all of them, so I don't know. But yeah, but basically this is, okay, if we, and for every edge with its rate and time, if we have time left over to take this edge, then we just recursively go to that node. This is the set of nodes that we visited, and then we just subtract the time, right? So this is very recursion, very good. So okay, so this is the brute force. I think this is straightforward ish. I mean, if you're here watching a Q4 video, I expect you to know how to write brute force. If not, just study this a little bit. I mean, I don't know if there's that much to explain, but if you do have questions, feel free to ask, because I'm learning as well to kind of think about what kind of questions people might have. So don't take it as you not understanding it. Take it as me forgetting to, or did not anticipate answering questions. So yeah, so this is the brute force. So the question is, why is this fast enough? N is 1,000. You're doing some kind of, Larry, you're doing some kind of crazy recursive type thing. One thing to note from the top is that note there are most 4 edges. Okay, fine. So that makes the problem slightly easier, but it's still at worst 4 to 1,000, right? Like in a very general case, this is 4 to the n, or another way to put this is very slow. Okay, so then you may ask yourself, okay, so why does this work, right? So that's the part that is a little bit awkward, is noting that this part, this part, and reading this part correctly is the tricky part about this problem. And I actually did read it correctly, but somehow I kind of wasn't able to prove to myself in a good way, or I had separate ideas in my head, but I didn't put them together. Because if you watch me solve this problem live, I said something like, and you could actually, well, let's go over this, right? If time is at least 10 and the max time is at most 100, that means that at most this is 10 recursion, right? This means that we take at most 10 steps, right? Hopefully this makes sense. I mean, it might not be obvious, but once it's pointed out, I think it's, it should make sense. So I did recognize this during the contest, and you'll see it in the video, but I still got confused a little bit with the n, because n is 1,000, right? And I think I was just a little bit confused with respect to a little bit of matters that I just didn't, it took me extra time to prove that brute force is good enough, because who would expect a brute force on Q4, right? I guess so, but I was wrong in that one, obviously, but that's what I was thinking. Why is this fast enough in total? Well, if this is at most 10 steps, that means that this recursion is at most 10 steps, and that means that actually at most this is 4 to the 10, or roughly speaking 2 to the 20, at least off my head. So this is like roughly 1,000,000, right? So with that, I was like, oh, that's going to be good enough. Maybe another way to put it, of course, is that if we can take at most 10 steps, then that means that, at most we care about 10 nodes, right? And that's pretty much the idea, right? Because at most we care about 10 nodes. Maybe that's not quite true. Maybe the first node has, so at most we care about 40 nodes, maybe, I guess, but independently almost, because for each like this set thing, we have at most 10 nodes. So recursion step, so we have 10 recursion each step. You could go 4 different ways into each step. So this is gonna be 4 to the 10. So that's basically the idea, and that's basically the quote unquote the gotcha, the trick, the thing to notice that's hidden away in a problem with 10 constraints. You have to look at this one and then really think about what it means. And the other ones almost don't even matter. Like this one doesn't really matter. This one doesn't really matter because most of these nodes are not even reachable. Most of these edges are not visitable, and most of these values are not even going to be touched. So yeah, so it's a little bit weird as a result, but this is why this is fast enough, and this is why the very good people got in 5 minutes. I could have done this faster, but well, I didn't because I don't know. I think some of it is, to be honest, is that it's hard to believe that brute force will be good enough for Q4. But yeah, I mean, you could see that this is 32 lines of code, and that's including a lot of stuff that I added just for for me explaining on this video. Anyway, that's all I have. You could watch me solve it live next, and I'll see you in a bit. What a silly mistake. Knew it. Okay, let's see how I was doing okay until the 5-minute penalty, and maybe even actually a lot of people got it very quickly, so maybe I'm well. But I was very slow on Q1. Okay, let's focus. Yeah, I was so quick. Maybe not. I thought I was faster. Time flies when you're having fun. Okay, from n from 0 to 1. Surprised no one finished this yet. Maximum quality of a valid graph. Got the constraint first, years 2000. So the max times 100, that may be interesting. Because that's just DP, I think. I'm surprised if it's DP, no one. Oh, well, someone finished yet. I was gonna say I'm surprised no one finished yet, but I'm wrong there. Wow, people are really fast today. Oh, A-Rise, nice. Really should have gone down faster though. Q2, Q3, but oh well. Okay, let's see. We always start at 0. Okay, fine. Maybe I messed this up. What? Hmm. Oh, you don't count the nodes more than once. Though I'm surprised that this skips infinite loop. Oh, whoops. Of course, I have the wrong answer. I misread this one actually. Hmm. Well, we actually can only go 10 deep despite what this tells you. So that means that we can only visit each, there are at most 10 numbers in this set. So, but how do you differentiate going now and a future one? Eh. So you can only go 10 deep-ish. Full edges connected each node, so Okay, I misread this one. Unique nodes, that's the key part. Okay. A lot of people got it though still, so maybe I'm missing something obvious. A lot of people got this already, so that's awkward though. I think this is too slow though without caching. For n is equal to 1,000. There was only 2,000 edges in total, so maybe there's some weird thing about that. Well, you can go back and forth, but it doesn't really make sense. It only makes sense if you want to go to the other side. Now we're thinking about it as a tree. Then essentially what we want to do is Other people are smart in this one. I'm not though. I mean, I think this is. I know how to do it, but I think I'm just overthinking it a little bit. Maybe, I don't know. I mean, I think it's just as annoying as my idea is, but I actually don't even know if that's fast enough. But also, it's not really a tree because you have stuff like this. So I think maybe I'm just a little bit weird on this one. How do you keep track then? I mean, yeah, I mean, we don't. This is not good. What we want is. Would have thought this would fix it, to be honest. But oh, it has to end at node 0. Oh, I missed this part actually. Okay, so this is actually way easier. Oh no, why did I spend so long? Okay, okay. This is way easier because is that true? Actually, I don't know if that's true. That is way easier, but but This has too many. This is too slow, to be honest. This is like 1,000 each. This is already crazy. Even if there's only 10 recursion steps. Maybe 10 recursion steps isn't so bad, I don't know. Well, yeah, this is so weird. A lot of people gotten it, so it must be something that I just don't know. But the starting at 0 part is a little bit dubious. Ending with 0. What does that mean? I have to draw it out. Maybe I try to think about it. Okay, I think I get it. The n is 1,000, but it doesn't even matter. Because you can visit at most 10 things. But if you have 4 choices between them, that's 2 to the 20, so that's 1,000,000. So that should be okay. Yeah, I think. Yeah, okay. I'm just being dumb then. I got distracted by the n is equal to 1,000. But that also means that I have to do this in a smarter way. What am I doing? Why not 32? Why am I having wrong answers on this one? What's going on? So weird. Oh, why did I did? I went 0. I guess before the bit mask was 1. That's why. Yeah. Hmm. Okay, now I'm right, but I don't know if this time's out, but let's give it YOLO. Okay, that was pretty dumb. I just didn't read the constraints correctly enough, and that's why everyone got it so quickly, and I'm gonna have a terrible score. Yeah, I mean, so no top 100 here, but and there's still 5 minutes of penalty. I misread the problem a lot for that one. I mean, I think that was a great problem in terms of analysis needed. But I was just not clutch on that one. Where's A-Rice? Congrats to Alex. Haven't seen him in a while, so good to see him doing well. Coming back. I mean, not that I have any surprise about that. Also, never give up. Give him a shout there. Always consistent. And really should have done better this contest, to be honest. If I am thinking about what I did, Q3 I was too slow. Wow, people are really fast. But it's a very standard-ish problem. I should have gotten that maybe. Well, definitely without the. I just kind of did the constraints without thinking, and that's how I got it. The 5-minute penalty, but also I should have done this in maybe. I don't know, closer to 3-4 minutes instead of 5 minutes, if you ask me. This one should not have taken that long, but I would have no excuse. I think I just or I just misanalyzed it for a long time. I got thrown off by this n as you go to 1,000. Yeah, I think this one was this. Actually, I mean, I think it's a cute trick that you have to notice, but it's kind of a crappy problem if you ask me, because I really could have gotten this very quickly. I had most of this win, but but I just didn't. I don't know. Like, I feel like it made more sense as a Q3 tricky type of problem, but it also seems like this is number one problem I have on some parts of Leetcode. On some problems is that they give you all these problems here describing a very generic situation, but then on the constraints it's like, okay, this is actually what's happening, you know. So I'm not a fan of this one per se, at least in the way that it's presented. Like, the problem is probably fine, but I think I just didn't do it that well. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord, especially if you like contest problems, or even if you just like to just hang out. See you later. Stay good, stay healthy, to good mental health, and take care. Bye bye.